Hi everyone, so we're back with another math lesson. Again, we are still learning about fractions. So today we are going to learn about equivalent fractions. So I'll make myself smaller and we'll get started. So before we get into the problem, we need to figure out what is an equivalent fraction. So I'm going to focus right here on this little green bubble, and we already know that fractions are a part of a whole. So equivalent fractions are fractions that name the same part of a whole. So that may be a little confusing, but we will get into it. So today we're going to start off with the essential question, which is how can different fractions name the same part of a whole? The question says, the Chisholm Trail was used to drive cattle to market. Ross's herd has walked 1/2 the distance to market. What is another way to name 1/2, or what is an equivalent fraction to 1/2? So it says that different fractions can name the same part of a whole. So that's what we are going to do. So let me zoom in a little bit. Here we go. We're going to start with A, or B, I guess. So it says 1/2 is equal to what? Our question, what we are trying to find, is what fraction can be the same or tell the same thing as 1/2. All right, so you can see here that they have a whole, a fraction strip that is just a whole, and they also put a fraction strip here that says 1/2 because that is what we are working with. Now again, we are trying to find a fraction that is the same as 1/2. So if you can see here, it says they have put two 1/4 fraction strips. So we have 2/4. It says the fraction 1/2 and 2/4 represent the same part of the whole. Two 1/4 strips are equal to 1/2, so 1/2 equals 2/4. Another name for 1/2 is 2/4. Now that may be a little confusing to you with the model, so I'm going to show you a little trick. All right, so this one looks a little bit different, but we're working with the same numbers. We have our whole, we have our 1/2, and then 2/4, so 1/4 and 1/4. So I want to show you a little bit of a pattern because sometimes the models for me get confusing. If you want to use them, please feel free, but I know my brain works a little bit different, so maybe yours does too. So if you see here, we have 1/2, and we have 2/4. Now, I know that 2 and 4 you can get from 2 to 4 when using multiplication. You can also get from 1 to 2 by using multiplication. So if I multiply 1 and 2 by 2, because I know that 1 times 2 equals 2, I get 2/4. So you can use multiplication to do this. How you do it is you take the top number, so your numerator and your numerator, and you figure out what you would times the first one by to get to the second numerator. So if I have 1/2, I know that to get to 2, I need to multiply 1 by 2. So then I have to do whatever I do to the top, I have to do to the bottom. So then I would multiply the denominator by 2. 2 times 2 is 4. So that's how I would get 2/4. Again, that's an equivalent fraction. It's the same thing as 1/2, the same kind of fraction. So I hope that makes sense. So I'm just going to keep going on the other page. So we found out that 2/4 is the same as 1/2. And now it's saying that you can find other equivalent fractions. So think about fractions that name the same part of a whole. So now we have here is a whole. We have 2/2, which equals a whole. Now we have 4/4. We remember that when our top number and our bottom number, our numerator and our denominator are the same number, it equals a whole. And we have 8/8, which also equals a whole. So all of these are equivalent fractions for one whole. So let's move on to the next example. All right, so I want to look at this, another example right here. It says you can find an equivalent fraction for 4/6 using an area model. So you might see one of these on the quick check. So you see here that both area models have the same size whole. One is divided into sixths. You can see here, I'll move myself. Can I move myself down? Move myself there. Okay, you could see here it's broken up into sixths, and the other shows thirds here. The shaded parts show the same part of a whole. So it's saying that 4/6 and 2/3 are equivalent fractions. So 4/6 is another name for 2/3, or 2/3 is another name for 4/6. Now, using the trick I just showed you, I'm going to take my smaller fraction here with the smaller numbers, and I am going to, it's not actually a smaller fraction, but the fraction with the smaller numbers. I see a 2 here, and I see a 3. So I'm going to look, what can I multiply 2 by to get to 4? So 2 times 2 is 4, and I have to do the same thing to the top and the bottom. So I would do 3 times 2, and that is 6. So we know that that is an equivalent fraction. So that's just another way to do it. All right, so here on number 2, it wants us to use the fraction strips to help us find an equivalent fraction. So it shows us here 1 whole, 1/4, and 1/8 and 1/8. We're just going to put these together. So 1/4 is equivalent to, how many eighths do you have here? I have 2 eighths. So I went ahead and wrote that for you. I have 2 eighths. Now, same thing with my trick that I showed you before. I'm going to see, what can I multiply 1 by to get to 2? So 1 times 2 is 2. So same thing to the top and the bottom. So I would multiply 4 times 2, and that is 8. So we know that works. So we know that an equivalent fraction for 1/4 is 2 eighths. All right, let's go to an example that looks like this. It says, divide the second area model into eighths. Shade it to show a fraction equivalent to 1/2. So instead of shading it first, I'm going to find my equivalent fraction before I shade it. This is easier for me. I will show you how to shade it, and you can do it first that way if it makes it easier for you. So I need to get, so I know it has told me that I'm dividing into eighths. So what I went ahead and did is I made my fraction with a blank up top on the numerator, and I have 8 as my denominator because that's what it told me. So I'm going to use my multiplication trick. Since I have to do the same to the top and the bottom, I can start at the bottom. So I want to know what times 2 can get me to 8. So I know that 2 times 4 equals 8. So I'm going to do the same thing to the top. I'm going to do 1 times 4, and I know that equals 4. So now I have it here that it's 4 eighths. I'm also going to show you how to do it on the model. So here it wants us to first turn it into 1/2 and then make it into eighths. So let's do that. All right, so I'm going to start off with, and I'm using a tool here, so it's not going to look exactly equal, but we're just going to pretend that it is. I'm going to go ahead and make my line for 1/2, making it as straight as I can. Then I'm going to take a line down here because I know that 4 and 8 kind of go together, so I can make 8 out of this. And then I need to make 4 more boxes. So if I split this one in 2, that's 4. And if I split this one in 2, that's another 4. So I have 1, 2, 3, 4, like I have here, out of 8 in all. I hope that makes sense. It's very hard to do on the computer. All right, and I'm just going to do another example here for you, just in case you see one of these on the quick check. It wants us to find an equivalent fraction for the fraction in the front. So here I have 3/4. I'm going to use my trick that I used before. I know that the top and the bottom I have to do the same thing, so I'm going to take my denominator and find out what multiplication I have to use to get from 4 to 8. I know that 4 times 2 equals 8. So same thing on the top as the bottom. So I know that 3 times 2 is 6. So an equivalent fraction for 3/4 is 6 eighths. So I know this might have been a little bit confusing, but I did take a look at the quick check, and most of the problems are like what we did on here. If you need any help, please let me know. You can also rewatch this video, or you can actually access this book through your Pearson login. So if you need help on how to do that, I can show you. But if you have any questions, please let me know and I will help you. Until the next video, I'll see you later. Bye.